Hi everyone, welcome to all of you in my lecture today. So today I'm going to talk about the nominal interest rate. So in the previous lecture, I have discussed about the depreciation calculation as well as calculation of simple interest rate and compound interest rate. So in compound interest rate, what we have observed that sometimes you will see that the length of time period n, which may not be 1 year. So or if the length of time period n that I was discussing, if it is 1 year, then the interest rate I, which is that is based on the yearly basis, so we can call it as a nominal interest rate. So I'll be talking about the nominal and effective interest rate. So let's say how we can deal with this nominal and effective interest rate. So even if when the actual interest period is not 1 year, then the interest rate is expressed on the annual basis, right? So sometimes they will give you the question in the form of monthly basis, hourly basis, or weekly basis, or daily basis. So I mean, all these compounding can be converted into the annual basis. So in this lecture, I will be talking about that how these kind of compounding can be converted into the nominal, annual basis. So let's try to understand. So let's say if I am talking about, let's say if 3% compounded annually. So what does it means? So if you can recall, S is equals to P into 1 plus R upon M whole to the power Mn. So if M is equals to number of compounding and R was your nominal interest rate. So here, if I'm talking about 3% compounded annually, so R equals to your 3% and M equals to your compounded annually, so M equals to 1. So let's say second B is your 5% compounded quarterly. 5% compounded quarterly, what does it mean? That means R is your 5% and M equals to your 4. So if you want to calculate S, so S is equals to, you can calculate P into 1 plus 5 divided by 4, and obviously 100 whole to the power. Let's say N is equals to 1 year. So you can write 4 into 1. So this is how the future value of present worth of P can be calculated. So P is your present worth of any particular assets, and M is your number of compounding, and again N equals to 1 year. So I just took 1 year in order to let you understand these things, and this is how you can calculate on the if the interest has been given as a quarterly. Now third, let's say if they are giving you 3% per quarter compounded annually. So this is very important to understand. Here they are giving you 3% per quarter and compounded annually. So I mean, compounding is done on the annual basis, right? So just wait 1 second. Yeah. So here you can see the compounding is being done on the annual basis. So your R will be equals to 3 into 4%. That is equals to your 12%, and obviously M will be 1. So based on this is how you can calculate these things. So you have to understand the statement, and once you'll understand the statement, based on that particular thing that is given in the problem, you can calculate. Now, let's say they are giving you 2% per month compounded monthly. So here R will be equals to 2% multiplied with 12. That is equals to your 24%. This is the thing that you need to understand. And obviously M equals to, since it is compounded monthly, so M equals to 12, right? So in this way, you will be able to calculate. Now, let's say next one, sometimes they can give you a 3% per quarter compounded quarterly. So how you can calculate these things? So your R will be equals to, since this one is R is also 3% per quarter, so 3% multiplied with 4. So that is equals to 12%, and obviously M equals to, that is compounded quarterly, so that will be equals to 4, right? So in this way, you will be able to calculate this value of future value of any particular assets if present value and R value is given and all. Now, this was all about the nominal interest rate, but now I'll be talking about the effective interest rates, because sometimes in the problem they can also ask you to calculate the effective interest rate if nominal interest rate is given, or sometimes they will give you the effective interest rate. They will ask you to calculate the nominal interest rate, right? So let's see how we can calculate the effective interest rate. So if I want to define the effective interest rate, so it can be defined as the annual return on the principal at which we are getting the money, right? So I mean annual return on the principal on which we are getting the money. So let's say it consists of two contributors. So if you'll see, one contributor will be your nominal interest rate as well as the compounding effect, right? So I mean here, if you'll see, effective interest rate consists of two factors, that is nominal interest rate and number of compounding factors. Very, very important. These days you will see that questions is being asked from here, this particular concept. So because of these two factors, what will happen? The overall interest rate will get increased, and this increase in interest rate is known as the effective interest rate. So let's say if you will increase the compounding, that means if let's say I am telling you, and uh, the value of future value of assets after, you know, if it is compounded annually, but now if it is compounded monthly, if it is compounded, uh, let's say weekly or daily basis or hourly basis. So hourly basis will give you maximum interest, right? So in that case, you will see the maximum interest is, if you are increasing the number of compounding, then you are getting the more interest rate, right? So I mean these factors will come, and how these things can be calculated, let's try to understand. So I'll be including these two factors in the effective interest rate. So the effective interest rate formula, you will see, that is equals to 1 plus r by m whole to the power m minus 1, right? So from the formula, you can see here that here r is your nominal interest rate and m is your number of compounding. So once you will be able to calculate the effective interest rate, now directly you can substitute this value in your formula, and you can calculate the value of any particular assets in the future and present time, right? So this is how the effective interest rates can be calculated. So I mean, now if you want to calculate the value of assets after sometimes, let's say s. So now s is equals to p into 1 plus. Now directly you can calculate and I'll tell you later on how we can substitute this value and we can calculate this value thing. So sometimes they will give you R. They will ask you to calculate effective interest rates, or sometimes they will give you effective interest rates. They will ask you to calculate the nominal interest rate. So this is the relation between the effective interest rate and nominal interest rate, right? So now, what I have told you, that if you will increase the number of compounding, so the interest rate will get increased, and the increase in interest rate you can observe from here. So if you will increase the value of m, the effective interest rate will increase. So that depends upon the value. So but now, if what will happen if will 10 m tending to infinity, so in that condition, when time period of compounding that becoming extremely small, or number of intervals is becoming extremely large, so then the interest rate will be calculated by the help of the continuous compounding. So the concept there I'll be talking about is the continuous compounding. So here sometimes this can be, it seems to be very impractical, but sometimes this kind of concept can be used, and you will see in the question. So in the gate examination, it can be given. That's why I'm teaching here. So that is a continuous. So when the number of m tending to infinity, number of compounding tending to infinity, or number of, compounding interval will get reduced very small. So then in that condition, what will happen? You can calculate s is equals to p into e to the power rn. S equals to P into e to the power Rn, right? So where R is your nominal interest rate and obviously N is your number of years of compounding. So, and obviously you must be knowing S is your future value and P is your present value, right? So this is how this particular thing works, and you can calculate this when these things has been compounded continuously. So this was the concept all about your effective interest rate and compound interest rate, continuous compounding. Now I'll be talking about very important property, concept of plant design economics. And repeatedly these kind of questions can be asked in the exam, used to be asked in the exam, and that concept is called as the annuity. And this kind of annuity concept, you might be, once you will join a job, so there you will be getting some kind of salary, and you will try to do some kind of investment in your coming future for the future, to get some good amount of money after your retirement. So your that kind of things, your retirement value, the money, or the pension scheme that you will be getting, that is based on the concept of the annuity. So every month or every year you will have to pay some amount to your, in your permanent account number. I don't have that much idea about that thing. So from there, after your retirement, you will be getting that amount of money. So this is how this thing works. So I'll be talking about the annuity here. So it is a series of payment occurring at equal intervals such that payment being made at the end of first interval. So let's try to understand how these things work. But I'll be, before going to write the mathematical equation, I'll be talking about the condition. Condition for the annuity is that first condition is the payment will be equal interval, and first payment made at the end of first interval. So already I have these things I have written in the, this exam, your definition. So what is happening here? Just try to understand. So let's say the service is an year, right? So here you will be getting the S, that is your future value. So what is happening? Let's say N equals to, let's say 1 year, N equals to 2 year, N equals to 3 year, and so forth. So what will happen? So let's say R amount of equal payment will be, you will be investing. So the cash flow here is R, 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 R. So what will be the value of this R at the end of another year? So the payment is being made at the end of the first year. So how much time it will take, in order to mature the value? So it will take n minus 1 year. So this value will take your n minus 2 year. So this value, for this, the time interval will be n minus 3. So what is your future value? S can be written as R into 1 plus I whole to the power n minus 1 plus R into 1 plus I whole to the power n minus 2, right? I'm talking about the future value, plus R into 1 plus I whole to the power n minus 3 plus so and so forth. And you can write R into 1 plus I plus R, right? So now you can see this is just a simple geometric progression in the mathematics. So you can directly calculate these things. As if you want to multiply I plus 1, that is equals to, you can write R into 1 plus I whole to the power n plus R into 1 plus I whole to the power n minus 1 plus so and so forth, and you can write r into 1 plus I, right? So you can write s into 1 plus I, that is equals to r into 1 plus I whole to the power n minus 1, right? R into, sorry. So if you want to calculate this value, so directly now what we can get that or I can directly write now, or it's better to write in that way. So S equals to R into 1 plus I plus R into 1 plus I whole square plus dot dot divided by S R into 1 plus I whole to the power n. Fine. And divided by R plus 1. Sorry, I plus 1. Sorry for that. You can write here is I plus 1. So finally, sorry, S is equals to, I can write R into R1 plus I plus R into 1 plus I whole square plus dot dot R into 1 plus I whole to the power n minus 1. Fine. So this is just a geometric progression. So what is the R, small r, that is equals to 1 plus I. So you can write S is equals to R upon I and 1 plus I whole to the power n minus 1. Directly you can get this formula. So if there is geometric progression, so what is the sum of series of that geometric progression? That is equals to a into r to the power n minus 1 divided by r minus 1. So here r was equals to 1 plus I. So a was your obviously r. So directly you will be getting this formula. Fine. So this is your future value of assets. When the compounding, I mean, when this process follows the annuity concept. So this is your future value. So if I want to calculate present value, so S is equals to P into 1 plus I whole to the power n. So where S is your future value and P is your present value. Fine. So now, how can I calculate the present value? So we know the value of S, that is R by I, and I'll substitute 1 plus I whole to the power n minus 1 divide equals to P into 1 plus I whole to the power n. So from here I can calculate P, which is your present value of the assets, that is equals to R by I, and I can write 1 plus I whole to the power n minus 1 upon 1 plus I whole to the power n. So now you have calculated the present value of the assets also. So these two formula are very, very important when we are talking about the concept of the annuity, when equal payment is being made at the equal interval of time and the payment is being made, the first payment is being made at the end of the last interval. So this is how the concept of annuity works, right? So after that, I'll be talking about one more concept, which is called as the annuity due. And I'm not talking about all these things. It is just a related concept with the annuity. So I'll be talking about just a mathematical equation. So let's try to understand these things. So here, it is a series of payment equal occurring at interval of time such that the first payment being made at the start of first interval. That's it. So in case of annuity, what we have seen that the first payment is made at the end of the first interval, but here the payment is being made at the start of the first interval. So if you want to calculate S of annuity due, that is equals to 1 plus I into S of annuity. So this is the basic difference between annuity and annuity due. So what is S? S is your future value and present value of the assets. Sorry, future value of the future value of all these are, which is compounded. I think it equal interval of time. So from here we have got the S annuity equals to S annuity due equals to 1 plus S annuity. So you have to remember only this formula. Obviously, S annuity we know that 1 R by I into 1 plus I whole to the power n minus 1 upon I. So from here you can calculate the S annuity due also. So in case this is your just a future value, and if they are giving you to calculate the present value of annuity due also, so based on this formula S annuity due equals to P annuity due into, you obviously you can use this formula I into 1 plus, sorry, this formula can be directly written, right? So these two concepts were very important, and that's why I have discussed about the annuity and annuity due. So most of the time you'll see this kind of questions has been asked in the examination. This is favorite topics of GATE examiner. Now I'll be talking about some next method for the, which is also based on the annuity, and that method is called as the sinking fund method. And this method is this one is a method used for depreciation calculation, which consider time value of money. So if you can recall my last lecture, so there I have talked about the depreciation method, which does not consider the time value of money, and that method was the straight line method, decline balance method, DTBM double decline balance method, and sum of year diesel method. So that does not consider time value of money. But now the sinking fund method is the method that consider the time value of money, and from there you can also calculate the value of depreciation, yearly depreciation of the assets, right? So let's say if your asset is having a value of V naught, right, at initial value, that is the original cost of the equipment or assets, and after the service life of an year, you are getting a value of VS, that is your salvage value, or you can say it as a scrap value. So now you want to calculate the yearly depreciation, right? Yearly depreciation. So let's say I'm assuming the yearly depreciation which follows the annuity concept, and this is equals to R, and the rate of interest is I, right? So how can I calculate this, the yearly depreciation value R? So if at the end of the service life, how much money I am getting, that is equals to, can I write V naught minus VS, and that is equals to R divided by I. Just we have studied these things, whole to the power n minus 1, right? So this is what we have just calculated uh, till now. So while using the concept of annuity, so where your V naught is your original value, VS is your salvage value or scrap value, and R is your yearly depreciation. So here in this formula, R is called as the yearly depreciation, and I is your interest rate. So your value of assets is getting decreased with the interest rate of I. So you can calculate the yearly depreciation. This value is R. So right. So with the help of this particular formula, and N is your service life of the assets. N is your service life of assets. But now you want to calculate the book value. So how can you calculate the book value? So what is difference between a scrap value or salvage value and book value? So salvage value or scrap value you will be getting at the end of the service life, that is your NFV and N year. But the book value is you are getting the as value of assets at a particular year, eighth year, let's say second year, third year, fourth year, fifth year, any year. So I can write that V naught minus VA, that is equals to R upon I, and 1 plus I whole to the power A minus 1. Simple. So the formula is similarly similar, where VA is your book value of assets. So now here you can see there is that depreciation method, that is sinking fund method. You know, this sinking fund method, you can see here that it requires the, I mean, in the formula you can see it considers the time value of money because the interest rate is there. That's why this method is called as the method which consider the time value of money for the depreciation calculation, and you can calculate the depreciation while using this particular formula of sinking fund method. I hope this thing is clear to all of you now. So now we have studied depreciation calculation. So sometimes they will ask you such kind of questions. So we have studied two kind of method. So method which do not consider time value of money, and second method, this one is first method which consider time value of money. So the question is that which method will be most fruitful for using the depreciation calculation, right? So the method which does not consider time value of money, this one is your best method. Calculate depreciation. Why? The reason is that in this particular method, obviously I have told you depreciation is the tools to save the tax, because you don't want to give more and more tax to the government. Since you will be starting your industry or organization, so you'll have to pay the tax to the government. But in the starting period, you'll see that you want that more money should be there in your organization and less money you want to give to the government as a tax. So if you are using depreciation calculation while the method which does not consider the time value of money, that will give you more depreciation amount or more depreciable amount in the early phases of your plant life or assets life. So you will be able to save more amount of tax and more cash inflow will be there. So that's why the method which does not consider time value of money is more beneficial in order to calculate the depreciation, and you will be able to save more amount of that. So this is what all about the topic of calculation of depreciation and time value of money. So now in the next lecture I'll be talking about the profitability analysis, and after that we'll start with the break even point. Okay, thank you all for watching the video, and if you have not subscribed my channel, please go and do like and subscribe my channel, and please you can also like the bell icon so that you'll get the notification whenever I'll be uploading the video. Okay, thank you.